Hi everyone. In the previous approach, we have seen how to segregate given array. But in the previous approach, we were traversing through the array twice. If you haven't seen previous approach, then I will provide a link in the video description. First, please go through that video. Okay, and then now in this approach, we will try to segregate given array with a single traversal. So what we will do while traversing, we will try to serve zeros and one. So while end of single traversal, we will have our array segregated. Okay, cool. So like what we can do, we can have zero and uh, we can uh, we can have I and j index. Like I will start from here and j will start from here. J will start from end of the array. So j will be n minus 1. Okay, and will be given number of elements in the array. Cool. So we will run a while loop and we will increase our I index and decrease our j index according to conditions. So while I less than j, we will have this condition. I should be always less than j, and if array of I equal to 0, then we will increase our I condition, because all zeros should come before all the ones in the segregate array. So if I array of I equal to 0, then 0 is already in the correct position. So first, okay, I will tell you output. So output should be like this. First 5 times 0. See, in the given array we have 5 zeros and we have 5 ones. Okay, so at ith index at line number 6, 0 is already at its correct position, so we will do nothing, we will just increase our I index. Suppose our j was here, see, so j is already at its correct position, because all the ones should come at the um, at the end of the array. So if array of j equal to 1, then we will decrease our j index. We won't perform sweeping because j is already at its correct position. Okay, so we have this case, and we can have this case also, like array of I equal to 1 and array of j equal to 0. So array of I should be 0 and array of j should be 1. So in this case we will perform sweeping. So but first we will check I less than j or not, because at line number 9 and at line number 12 we have I plus plus and j minus minus operations. So due to that operations, I index can become greater than j index, or j index can become less than I index. So we need to check here at line number 15, and array of I equal to 0 equal to 1, and array of j equal to 0. So we need to serve. So here we can directly assign instead of swapping. So array of I equal to 0 and array of j will be 1. So instead of swapping we can directly assign, and we will increase our I index and we will decrease our j index. Okay, so I will come here, I will come here, and j will come here, and after swapping we will have here 1 and we will have here 0. Okay, cool. So okay, so one by one we will traverse through the whole array and we will perform operations. Okay, cool. So first I will have given input. So Okay, this is given input, and initially I will be at 0th index and j will be at n minus 1 index. Okay, so first I will have I and j, then I less than j condition, then we have at line number 9 this condition, array of I equal to 0. So we have this condition, and then we have array of j equal to 0, this condition. Then we have this condition. Now we can check array of I and array of j. Okay, now we will have this condition, big condition, this big condition at line number 15. So it will be this. So if this condition is true, then we will perform I plus plus and j minus minus. Cool. So initially will be 0 will be I will be at 0th index and j will be n minus 1 index. See line number 6. So initially I will be 0 and j will be, for this case j will be 9. So this condition is true, 0 less than 9. So array of 0 here, it will be 0. This condition, array of 0 will be 0, condition is true. So what we will do, we will increment our I. So I will become 1. See line number 9, arrow of I equal to 0, then we will increment our index. So I will become 1, so we will increment our index. Cool. And we have line number 12, array of I j equal to 1. So array of j equal to 0 right now. So array of j equal to 0 and condition is false. So right now we have array of I equal to 1 and array of j equal to 0 we have. So 1 less than 0, I is 1 and j is 9. So condition is true. And array of I equal to 1, this condition is true. Array of j equal to 0, this condition is also true. Both conditions are true. Array of I equal to 1, this condition is also true. So we will come at line number 15, array I less than j, condition is true, and array of I equal to 1, this condition is also true. Array of j equal to 0, this condition is also true. So at line number 16 we will assign array of I equal to 0 and array of j equal to 1. So what we will do, array of I will be 0 and array of j will be 1. It will be 1. And we will increment our I index. So I will become 1. I was 1. So I will become 2 and j will become 8. So I will be here and j will be here. See. So we have I edge 2 and j edge 8. So this condition is true. And we have array of I equal to 0. This condition is true. So we will increment our I index. See line number 9. This condition is true. So we will increment I. So I will become 2. I was 2 only. So I will become 3. So I will be here. Okay. Then we have at line number 12, array of j equal to 1. So this condition is also true right now. Array of j is 1. This condition is true. So we will decrease our j index. So j was 8. So right now j will become 7. J equal to 7 right now. Right now array of I will be 1. Array of j equal to 1. So 3 less than 7. This condition is true. And array of I equal to 1, this condition is also true. Array of j equal to 0, this condition is false. So we have AND operator here, line number 15, AND operator. So whole condition will become false. So our code won't execute line number 16, 17, 18, 19. So we are running in the while loop. So we will directly go to line number 8. So right now we have I edge 3 and j edge 7. So this condition is true right now. and array of I equal to 0. No, we have array of I as 1. See line number 6. So this condition is false, so we will check line number 12 condition. Array of j equal to 1, so this condition is true. Array of j is 1, condition is true. So at line number 13 we will decrease our j index, so j will become 6. So j will be here only. So now we have array of I equal to 1, array of j equal to 1, and 3 less than 6. This condition is also true. This condition is true. Okay, and array of I equal to 1, this condition is also true, and array of j equal to 0, this condition is false. So overall condition will be false. So we want to execute line number 16 to 19. We will directly go to line number 8. So we will have I as 3 and j as 6. So this condition is true. Array of I will be 1 only. So condition is false. Line number 9 condition is false, and array of j equal to 1. Array of j equal to 1. Here it should be 1. Line number 12 condition. Here it should be 1. See here, array of j equal to 1. So this condition is true. So line number 13 we will decrease our j index. So it will become 5. Array of I equal to 1, and so it will j index will become 5. So it will be here. So array of j right now is 0, and 3 less than 5, it is true, and array of j equal to 1, it is true. Array of j equal to 0, this is also true. So all condition is true at line number 15. So we will execute line number 16 to 19. So we will assign array of I equal to 0. See line number 16. So I will be 0, and see line number 70, array of j equal to 1. So array of j will become 1. At line number 18 we are increasing our I index. So I will become 4. Okay, at line number 19 we are decreasing j index, so j will become 4. So we will increase I and we will decrease j. So I and j both will be at 4th index. See here, 4th index. So we have I as 4, j as 4, and this condition will be false, I less than j. So at line number 8 this condition will become false, 4 less than 4. Okay, so we will terminate our while loop, and at the end of while loop, see our array is segregated at line number 5. See all zeros in the array comes before all the ones. So this is the approach. We are traversing through the array once only, and at the end of the while loop we will have our array segregated. Okay, so now I will going to uh, write the C program for this approach. Okay, cool. So I will comment all these things and I will start writing code. So I will comment, I will have multiple line comment here. So first I need to include header file, standard input output .h. Then I will have main program. Then so return type of main program is integer, so I will return 0. So I will have int I equal to 0 and int j equal to n minus 1. Okay, so we will have here int n. Okay, here so it will be, I will take 10. So you can provide scanf and user will give the value to n. So here I will have array of n which is 10. So I will have this array given input array. Cool. Okay, so I will apply a while loop here, while I less than 10, I less than j. Okay, And in the while loop, first I will have this condition, array of I less than I equal to 0. See line number 5. So if array, array of I equal to 0, then what I will do, I will increase our ith index. So I should be increased if array of j equal to 1, then I will decrease my j index. If the array of j equal to 1, then I will decrease my j index. So here it will be j minus 1. If so, after increment and decrement, maybe I becomes greater than j. So I need to check here. Still I is less than j or not. If array of I equal to 1 and array of I equal to 0, then we will save. So we need to enclose this statement in parentheses. So we will provide curly braces and we will assign array of I equal to 1, I equal to 0. So we can save also, but here no, elements in the array are 0 and 1. So I am directly assigning j equal to 1. So I will increment my I index and I will decrement j index. So this is the approach. So now I will run this program and we will see the output, and I should have for loop for printing the output. So we can confirm like we have segregated our array correctly or not. Okay, so I plus plus, and I will have a print statement here. Okay, so it will print array of I. Cool. So we have our program. Now we will run. We have done with our code, and now we will run this program and we will see the output. Okay, so see, array is segregated. See the output. So this is a dynamic program. It will work for any given input. Like we can have here 0, here we can have 0. Okay, now I will clear this previous output. Now I will run. See, we have in the line number 15 we have 3 1. See, this array is segregated. So this is a dynamic approach. So it will work with any given array. So here time complexity will be order of n. Okay, and we are traversing this array only once. So time complexity will be order of n, and space complexity will be city will be 1 only, because we are not creating any new array. Only we are using variables like I, j, n. Okay, so what I will do, I will provide a link in the video description. From there you can get this source code. Okay, cool. Okay, bye.